Have you ever wondered what's actually in the air you're breathing? I don't mean the citywide average. I mean right on your specific street, right now. Well, we're about to take a deep dive into the Sparrow node. It's this incredible device that can turn a normal car into a high-res environmental scanner. And by the time we're done, you're going to see just how much brilliant engineering it takes to make the invisible visible. So, this thing, it might look like something out of a sci-fi movie, but it's a real-deal scientific instrument. As a car just drives around, this node is constantly, well, tasting the air. It's grabbing millions of data points on everything from traffic pollution to factory emissions, and it's building a map of our environment we've just never been able to see before. And that's really the big question, isn't it? I mean, how do you build a super sensitive piece of lab equipment that can survive on the roof of a car, dealing with wind, rain, vibrations, all while collecting data that's pinpoint accurate? The answer, it turns out, is in some seriously clever engineering. Okay, so let's get down to it. What exactly is this device? Because it's way more than just a simple sensor. It's a fully autonomous system, and it's designed for a very, very specific and challenging mission. To put it simply, think of this as a mobile science lab. As it's moving through a city, it's constantly sniffing the air for pollutants, things like particulates and different gases. Then, and this is the cool part, it automatically beams all that street-by-street data back for analysis. No one has to do a thing. So now we get to how this thing is actually built for the road. Its physical shape is totally dictated by its job. Every single curve, every design choice, it all serves a purpose. It's this perfect blend of aerodynamics, toughness, and just absolute simplicity for the person using it. Look at that smooth, curved shape. That is not just for looks, not at all. It's designed to be aerodynamically stable on top of a moving car. The nose, which is what the manual actually calls it, is shaped to cut right through the air, minimizing drag and making sure this thing stays put even at highway speeds. The whole design philosophy here is just radical simplicity. Think about it. The user might be a delivery driver or a city worker, not a scientist. So for them, there's only one button. You press it, it lights up, and that's it. Your job is done. The device takes over and manages everything else itself. It makes a super complex scientific tool incredibly easy to use on a massive scale. And this is just a brilliant solution to a huge design problem. How do you attach a sensitive instrument to a car without any tools or permanent holes? Well, the answer is 5 incredibly powerful rubber-coated magnets. They give it a death grip on the roof without leaving a single scratch on the paint. But the design only works if you put it on right. And where you place this thing is absolutely critical. The rules in the manual, they aren't just suggestions. They are hard limits, and they're dictated by straight-up physics and safety. The nose has to always face forward. And what's so fascinating about this is that it has nothing to do with the quality of the data. It's purely for aerodynamic stability. The whole shape is designed to slice through the air in only one direction, kind of like the wing of an airplane. So, and this is the crucial point, this isn't just a friendly tip, it's a fundamental safety rule. If you face it the wrong way, it goes from being this sleek, aerodynamic shape to basically being a sail, and that could cause it to just rip right off the vehicle at speed. Along with which way it's facing, there's another hard limit: speed. The manual is very clear: a maximum of 120 kilometers per hour, which is about 75 miles per hour. And, you guessed it, that number is not just a random suggestion. It's a very carefully calculated safety threshold. Right? So the manual puts it in those technical terms, but what it really means is simple. Go faster than this, and you are fighting physics. This is the calculated point where the force of the wind could actually overpower the magnetic force holding it to the roof. It's a non-negotiable safety limit. So the entire installation process, it really just boils down to 4 simple, precise steps. You clean the surface to get a perfect seal, you align it with the nose forward, you lower it straight down so all 5 magnets grab on at the same time, and then you give it a little wiggle to make sure it's locked in place. Every single step is designed for a secure, safe attachment. All right, so once it's on there and physically secure, the device's autonomous brain just takes over. This is where that set it and forget it design really shines. The hard part is done, now the tech does all the work. It's really designed to be a true black box. You just plug it into the car's 12-volt outlet for power, and that's it. It handles the entire scientific mission on its own. It connects to the cell network, sends its data, gets updates. The driver doesn't have to do a single thing. So you might be thinking, why go to all this engineering trouble? What is the ultimate point of this elegant, tough, autonomous little machine? And this is the big payoff. When you have a whole fleet of these devices out there, you create this living, breathing map of a city's air quality. You can literally see pollution hotspots flare up during a traffic jam, or track a plume from a factory, or even see the difference in air quality between a park and the busy street right next to it. That's a level of detail that was just impossible before now. Ultimately, the Sparrow node leaves us with a really powerful question. By making this invisible world of pollution visible, block by block, it gives us more than just data. It gives us the power to make smarter decisions about our cities, about our health. So the real question is, now that we can see it, what are we going to do about it?